So let's now practice finding the missing sides on a 45, 45, 90 triangle. So if I look at my first example, I notice this is an isosceles right triangle. Each base angle must be 45 because 180 minus 90 is 45, and 180 minus 90 is 90, divided by 2, these are each 45. So I'm going to put that in. And I know right away that C is also 6 root 2. Now at this point, I actually could use the Pythagorean theorem to find side D, which is the hypotenuse. Or I could remember the relationship between the leg and the hypotenuse that I learned in the previous example. I can see that the leg is always going to be multiplied by the square root of 2 to get the hypotenuse. Therefore, I can take my 6 root 2, multiply by the square root of 2. Now remember, radicals multiply radicals, numbers multiply numbers. So this is 6 root 4, but the square root of 4 is 2, so 6 times 2 is just 12. And I would know that side D is 12. And this makes sense, right? Because 12 is the biggest side. It makes sense that it's across from the biggest angle. Another way that I can think about it is to use the concept of similar triangles that we learned before. If I understand that this triangle with leg 6 root 2 is just a scaled up version of the original triangle 1, 1, the square root of 2, I can use ratio and proportion to solve for x. So I can say that 6 root 2 corresponds to 1, right, here to here, just like x corresponds to the square root of 2. And I can cross multiply, solve for x, and get the same result. Okay, so you can use the concept of similarity, ratio and proportion, realizing that this triangle is a scaled up version of the original that we proved to get the same result. Okay, let's go to the next example. So here, this is a little more interesting. I have the hypotenuse. I need to find the two legs, and I know the two legs are going to be congruent. Well, now to go down in size, since I need something smaller, instead of multiplying by root 2, I'm going to divide by root 2. So I'm going to take 15, divide by the square root of 2, but we all remember that we cannot have a radical in the denominator, so I need to multiply by my fancy 1, and I need to say that this is really 15 root 2 over 2. So I know that side G is 15 root 2 over 2, and I know that F is 15 root 2 over 2. Now, if you didn't believe me, you can go back and check. What if I wanted to go to from the leg to the hypotenuse? To go bigger, I'd have to multiply by the square root of 2. If I did that, 15 root 2 over 2 times root 2, this would give me 15 times 2 over 2, and I would get 15. Let's go to the next example. Okay, this is a little easier. 2, that's a 2. And to go up to the hypotenuse, that would just be 2 root 2. Here, same as example 15. I have the hypotenuse. I know those are both equal. So I know this is a 45, 45, 90 triangle. And I can just divide by the square root of 2 to get my smaller number. So 5 divided by root 2. Again, I have to rationalize. I get 5 root 2 over 2. And that is the x value that I'm looking for.